Okay, so I welcome everyone. Let's get started. Um, we will take a few minutes to just recap everything. So before we start, I just want to make sure that we can, all if you can see me. So let me just switch on the camera for a minute. Okay. So let's do this. Let's go to the camera and okay. So hi everyone. In the last session, we talked about reflection. We understood certain basic concepts. I also explained the concept of an image, and it is extremely important that we understand that concept really well, right? Because rest of it, what I'm going to teach today, I'll teach for about an hour or so. We are going to build on that. Okay, so I will just start. I'll do a very quick, a few minutes quick revision of the idea of an image, and then from there I will start asking questions about specific questions on image formation. We will first start with a concave mirror, and then we'll move to a convex mirror. Okay, and my goal is to make it very simple, easy to understand, intuitive, and do it in a way where you start understanding, because in school textbooks and other places also they explain, but the core concepts are not explained in a way where children can understand. The intuition is very hard to build, so my goal is to help you build that intuition. Okay, so let's do that. As always, feel free to ask a lot of questions. I'd be happy to answer. Okay, so let's get started. Okay, so now let's get going. Let's see. First question I would like to ask is, last time we mentioned, we talked about image formation. Just I want a quick recap. Okay, so here we go. What does image formation by spherical mirror mean? Right? In fact, I would say in general, what does image formation mean? Image formation means, I'll just repeat, okay, all of you make sure you understand this. So let's say there's an object. Okay, let me actually take a red colored object. There is a red colored object. Okay, and this object is reflecting some light. Okay, and there are light rays which are going in all directions. Lots of these, infinite number of light rays are going. And now let us say, if all these light rays, let's say if I put a mirror or something, right, and all these light rays after reflection, right, all these light rays after reflection, let us say they went and they came and met at this particular point. Okay, let me use a different, okay, after reflection they don't change color, but just to show you, I'm going to use a different. So let's say all these rays after reflection, they come to this point, right? They come to this point. Okay, so this is all the rays coming after reflection. Very, very basic. Sorry, they're all coming like this. Okay, now just try to understand what happens. Okay, these rays, I'll go very slowly. Okay, these rays are going from here. Ray number 1, ray number 2, ray number 3, ray number 4, and after reflection, they're all coming and meeting here. Right. So this object, whatever it looks like, this point will look, I mean, if I put a screen here, okay, if I put a screen here, what I would see so these two things would look the same, right? So we can say that this object, okay, let me just change I'll use blue here. Okay, so this thing will look exactly like this thing, so we can say that this is the image, this is the object. Okay, so which means the core idea is, image is where rays meet after reflection or refraction. Refraction is when we talk about lenses, it will come later, but the concept is same. Okay, So image is where the rays meet after reflection or refraction. This is a quick recap. I will now start using these concepts, and you have to make sure that you have understood this. This is very core to it. Okay. We have talked about real and virtual. Okay, we did not talk about inverted and erect. So I'll do one thing. I will actually show it to you. Okay, when we do the image formation, we will learn these things. But right now, I'll just like you to know one thing. Okay, I would just like you to know one thing, which is that I will give you some properties of real and virtual. I have not proved it to you. I'm just telling you. I will show it to you as we do our ray diagram. So real image. Sorry, real image. What are the differences? One is real image. Second, rays actually meet. Right. In case of virtual image, rays. Oops. One second. Let me just make sure I lock this. Okay. Okay. So there's some glitch here. That's fine. So here rays actually meet, and in virtual rays. What's going wrong? Rays meet. Some there is some problem with my device. Just bear with me for a second. Okay. Okay, let me just close this and I'll start again. There's some glitch here. So hopefully it should not be a problem. My iPad is giving me some trouble. Don't worry about it. Let me just open a new page and see if I can, sorry. Okay, give me 1 minute. Let me just restart my iPad. Seems like there is some problem here. Okay, let me see if it's now sorted. My iPad is behaving weirdly, but I hope it won't. Okay, so I'm assuming that will work fine now. Let's see if you're lucky or not. Okay, so rays actually meet. This is in real, and in virtual, rays meet when extended backward. Okay, this is one property. Second property is that in case of real, image is always inverted, and why you will see this. Okay, so don't worry about it. I'll show it to you. It's inverted, and here it is erect. Okay, and diminished and magnified, it does not depend upon real or virtual. Both can be real image and virtual. Both images can be either diminished or magnified. Diminished means the image is smaller than the object, and magnified means the image is bigger than the object. So we will get to see all that. Okay, now this is the fun part. Okay, now the real science starts. Okay, are you guys ready? Let's do that. Okay, so first question is how do we, so let's say here I have a mirror here. Okay, this is a concave mirror. Okay, this is a concave mirror. Now I put an object, and normally we use an arrow. What is arrow? Arrow, it can be any object. This I've just chosen some object. Okay, now the question for you is, how do we find where this object, right? How do we find where the image is going to be formed? How do we find where the image will be formed of this object? Now you might want to refer to, I'll give you some time to think, right? What did we say? Where will the image be? So let's see if I take, and I'm not even talking about the whole arrow. Let us say I take the tip of the arrow. Okay, I take the tip, this point. Okay, tip of the arrow. The question is, where will the image of this tip be formed? How do we find out? You have to think and tell me. I'll give you half a minute or 45 seconds to think about it. Remember what we said earlier, image is where the rays meet after reflection, right? So that's the hint. Now think and tell me, how will I find where the image of this blue dot is going to be? I want some answers, guys. So you have to think and tell me. Okay, so I have given you enough time to think, right? Now let's now figure out. So what did we say? We said that, by the way, here in everything I'm teaching, just use your common sense. Don't worry about, oh, this diagram, that diagram. Just think about it the way you would think using common sense. Okay, so what are the definitions? So image is going to be formed. Image will be formed wherever the rays reflected, wherever the rays coming from this point are going to meet. So let us say this point, it is going to send rays. How many rays? Infinite number of rays. This is one ray, this is second ray, this is a third ray, fourth ray. I can draw infinite number. And what will happen to all these rays? They will get reflected. In what direction? They will get reflected as per the law of reflection. So if I take this particular ray, if I take this ray here, still facing a small problem, but hopefully it should not be very problematic. Let's hope so. Okay, so if I take this particular ray here, what will this ray do? So it will come and get reflected. What direction? So here roughly the normal is going to be like this. So this ray after reflection will maybe come in something like this, right? So let's now draw this. I am going to now draw this. So this ray, this first ray will get reflected. So maybe let us say this. So let's say this is the, So this, let's say this is the normal, okay? So it will get reflected something like this. It comes, let's say, here. What will happen to this ray? This also will, there'll be, it's, sorry guys, my iPad is giving some problem. I think it's got some technical problem which I can't figure out. If it doesn't, if it gives a problem again, I'll just restart it, right? Okay, so by the way, one of you have said reflect and the focus point is where the image is formed. No. So focus, image is not formed at the focus always. When is image formed at the focus? Only when the object is at infinity. And this is for you also, okay? The object here, remember, the object here is not at infinity. Object is at a given distance. This has to be very far for the image to be formed at infinity. Here what will happen is, like I was saying, this ray comes here. Here, let's say this is the normal, so it will get reflected like this. So each of them would, this would go back like this, right? So each of the rays would get reflected and they would go and meet at some point. Okay, that is the key. So all these rays, this ray, they all coming and meeting at this point. Sorry, actually I have not drawn it properly, but they'll meet at some point, and I'll show you where. But this is not where the point will be. Here I'm just doing a rough drawing. But wherever they meet, that point is going to be the image of this point. Does it make sense to you? Is this much clear? Okay. Wherever all the reflected rays go and meet, that is where the image of this point is going to be. Very simple idea. If you understand this, then we can build on it, and it should be pretty easy to figure out the image formation. Okay. Now I'm going to give you 10 seconds to absorb this. Absorb this. If you have any questions, you can ask me also. Okay, so now let's get started. Okay, so next question I have for you is, I wanted to, let me ask a question here. Now the next question is, I have a mirror here, and this is the principal axis, this is the pole, this side is this. From this side you have done silvering. Now the question is, if I have an object like this here, okay, I want to find the image of this tip. Now there are going to be infinite number of rays coming from here. There'll be one ray, second ray, third ray. I can draw infinite number of rays. My question to you is, how many rays? And all these rays after reflection, they will meet at some point. Let us say all these rays come and meet at this point. Let's say this ray comes here, this ray comes here, this ray comes here. All these rays come and meet at the same point. So the question for you is, how many rays should we draw? Should we draw 3 rays, 4 rays, 5 rays, 10 rays? How many rays should we draw to find the meeting point after reflection? And the answer is 2 are more than enough. Why is that? Let's understand. So let us say you, couple of you and your friends, you are going to meet somewhere. Okay. Now this is say your house. This is another friend's house. There's another friend's house, right? This is another friend's house. Now all of you are planning to meet. Now somebody wants to find out, okay, where are all these kids going to meet, right? Now what will that person do? Let's say if he sees you walking, right? You are walking and you're going along some path, right? You are walking. if the person looks just at you, right, he will not be able to find out where you're meeting. But let's say you are walking and he sees that okay, your friend is also walking, and both of you come and meet here. Now they know that okay, meeting point is here. Now they don't have to see where this guy is going, because he is also going to, since the meeting point is here. Now we know that everybody everybody is going to meet at the same point, right? So what do we see here? We see here that as long as we know where, okay guys, what we'll do is my iPad is creating some problem. I will have to give you a 5 minutes break. So all of you just take a 5 minutes break, just go and have a glass of water or whatever, and come back in 5 minutes. Let me try to reset my iPad. Okay, I'm facing some technical problem. Okay, sorry about this. I didn't expect that. Let's just take 5 minutes and hopefully it will be sorted. 5 minutes break. Okay, children, so we are back. I have restarted my iPad, so hopefully now we should not, let's hope and pray, right, that we will not face any problems. Okay, so I hope all of you are back and we can now get started. Okay, so the answer was, okay, so let's now try to focus because last time we got a little distracted. Okay, so the question was, if 5 of your friends are meeting, right, I don't have to wait for all 5 of them. As long as 2 of them meet here, then I know that this is the meeting point. Once I know there's a meeting point, then I know this guy will come here automatically. This guy will also come. This guy will also come. Everybody will come there. Right? Same concept applies to finding out when we try to find out where the image is formed. And this is again something which is never. It's not explained very clearly. It is explained, but not that clearly. So which means that if I am looking to find where the image of this point is formed, I need only 2 rays. Either I can, and which 2 rays? Let's say right now I have ray number 1, 2, 3, 4, 5. Which 2 should I pick? That's also a question, right? And the answer to that is pick any 2 whose behavior you know really well. Let me explain to you what I mean. Okay. Now let us say there is a concave mirror. Okay, and this is the principal axis. Okay, this is the pole. Now there is an object here. Okay. Now the thing is, and let's also draw a couple of other things. So let us say this is the center of curvature. Okay, and where is the focus going to be, guys? Remember, what did we say? We said focal length is equal to half of radius of curvature. Once again, focal length is going to be half of radius of curvature. What is the radius of curvature? This distance is the radius of curvature. So focal length is going to be half of it, right? So which means my focus has to be between the center and the pole. So this has to be the focus. Makes sense, right? Okay, now this is the critical part. So now I'll go slowly and I have to make sure that you guys have fully understood. Okay, I can draw many rays. I can draw a ray like this, like this, like this. I can keep drawing, but the problem is all these rays, their behavior will have to draw normal and then find the angle. That's like very, very hard, right? We don't want to, see, we are smart children. We are smart people. So we don't want to spend our time doing things in a manner which is not efficient. We want to do it smartly. So they'll say, okay, you know what? I'm not going to take some random ray. This is not a good idea. Why? Because I have to do all this thing. What I'll do is I will take some rays whose behavior I know really well. This is interesting. So the next question is, so which ray's behavior do you know well? Can you tell me? I'm sure if you think you can. Which ray's behavior do you know? One you know. Okay, one behavior you know. What is that? If a ray goes parallel to principal axis, after reflection, what happens? What happens? Tell me. After reflection, this ray will go through the focus. This is something that we already know. Okay, so now I'm going to write the behavior, right? So what we'll do is we'll look at some rays whose behavior we know. So one is ray parallel to principal axis, right? It will go through focus. Focus. Don't take notes now. I'll tell you when to take notes. Okay. Right now, just watch and just enjoy. Okay. So this is first point. Tell me, all of you, please confirm that this is clear to you. Okay. When you confirm, I'm going to move forward, but I want a confirmation from you that this is clear. Okay. Good. Now next is next question I want you to think and tell me. Think very carefully, okay? If a ray goes through the focus, if a ray goes through the focus like this, I have used a black color. Let me use a red color itself just to be consistent. Okay, if another ray goes through the focus, what will happen? What will this ray do after reflection? So this ray, and this is, maybe it's not that obvious, but I'll just tell you, this ray is going to go parallel to the principal axis. Why? Think about it. Think and tell me. Here's a question for you. A ray going ray going parallel will come through focus, but a ray going through focus will also go parallel. Why is that? That is because there is another principle which is called principle of reversibility of light. I'll write it here. Principle of reversibility of light. What does it mean? What it basically means is that if let us say I have some lens, mirror, whatever, right? I have, let's say, a lens here, a mirror here. You learn about lenses later. And I have, let's say, a ray of light which goes like this, then it goes like this, then it goes like this. Let's say something like this, right? What this says is, and listen very carefully, okay? If the ray goes like this and then comes back like this, if I were to reverse the direction, once again, if I were to reverse the direction, instead of sending like this, instead of sending from here and here, if I send from here, it would take the opposite path. So which means if I send in the opposite direction, it would take the same path. Regardless of what, you can have any kind of setup. It can be as complicated. You can have one lens, you can have 10 lenses, you can have mirrors, you can have whatever. If the ray goes like this, then if you reverse the direction, it will follow the same path but in the opposite direction. This is called the principle of reversibility of light. Okay. So the reason now here, the way to think about this is, and this will be like very interesting for you. Okay, let's say if I had sent a ray like this, I'm using green color. What would this ray do after reflection? We know that it would go through focus. Yeah, correct. A ray which goes like this, it would go through focus and would reach here. Which means that if this ray would go like this, then by definition a ray going through focus will also become parallel. This is the idea. Okay. So now I can write for you. Okay. So first is ray parallel to principal axis will go through focus. Second, I will write. In fact, what I'll do is I will write all of them on this one page so you can see them here. One, ray through okay, ray, I'll repeat that, ray parallel to principal axis, right? It will go through focus. Okay. Second, ray through focus, after reflection, what will it do? It will go parallel to principal axis. Okay, these are two behaviors that we know. What else? I'll now pose a question. Okay, I'll now pose a question. Think carefully. Okay, I'll give you some time. This is actually a fun question. Okay, here's the question. If I take a ray which goes through the center of curvature, once again, if I send a ray through the center of curvature, what will this ray do? A ray through center of curvature. Now, in case you are not sure, I will remind you of something. Should I do that? I will remind you of the property of a circle. What is the property? Property is that, so let's say this is a circle. Okay, This is the center, and if I take a line from, draw a line from the center, to any point. Let's say this was a mirror, okay, let's say this was a mirror. What would happen? This ray falls here. What is the angle with the tangent here? If I draw a tangent, what is the property of a circle? That the radius makes 90 degree with the tangent. This is a property, which means a ray which goes like this will come back like this. This is the point. Now here, this is the center of curvature. So this mirror is almost like, this was part of a big circle, correct? So which means that when a ray goes to the center, okay, when this ray goes to the center, it is going to get reflected back. So now what I'm going to do is I'm going to draw these, instead of making this a mess, I'm going to draw them one by one. Okay, so let us actually do that. It will be better if I do it one by one. So I'll delete some of the, I don't need this. I'll delete this page. Okay, and I will okay. Now let us do one by one. I'll draw separate. Let me clean this up a little bit. Okay, I will. Okay, now I'll give you some time to take notes. Okay, so first thing I want you to do is, let me also remove this. This is fine. I don't want this ray. Actually, let me just draw this thing again. Okay, so first we'll draw case by case. Okay, so case number one is, we have a concave mirror, okay, and this is the principal axis, and this is your object. This is, let us say, your center of curvature, and this is your focus, and this is the pole, and a ray which goes parallel after reflection, it goes to the focus. Okay, this is the now I would like you to write this down in your notebook based on your understanding. Don't copy. Okay, don't copy it from the screen. Just think, understand, and then write it. Okay, so a ray parallel to principal axis will go through focus after reflection. Okay, so I want you to write this down and write it down in your own words. Okay, screen is cut a little bit, so I'm going to just move that a little bit. Okay, great. Next I will just copy this here, this particular screen, and we'll make a, okay. Okay, now tell me one thing. Now, oops. Now we are not going to take this particular ray. We'll take a different ray. Now the next, this is the focus. a ray through the focus, it will go parallel to the principal axis. Okay, so this also I want you to write down. A ray through focus will pass, will go will become parallel to principal axis after reflection. Okay, this is number 2. So I want you to again write it down in your own words, the way you have understood. Please don't copy it from the screen verbatim. Meanwhile, somebody whose handle is beast within said, sir, I don't understand. Can you let me know what is your, if you can just type your question, I'll try to answer that. Okay, so now we have looked at the second scenario also. Now let's go to a third scenario, which is that when we have a, I'll again take a concave mirror, I'll draw a line as usual. Okay, this is the pole, this is say the center of curvature, middle point, this is the focus, and I have my object here. Now if I draw, and this I'll ask you to think carefully and tell me, if I take a ray which goes like this, a ray which goes to the pole, after reflection, what will happen? Where will the ray go? You have to think and tell me. A ray which goes like this, after reflection, where will it go? The answer is actually not very hard. What is the answer? The answer is that this is the pole, right? So as you know, if I take a tangent here, right, then the angle between the principal axis is the normal, because this angle is 90 degrees, correct? So which means it will get reflected such that this angle is going to be equal to the angle of reflection. So it will get reflected such that, like this, maybe a little smaller angle. Yeah, let me try again. Yeah, something like this. Okay, so that this angle is theta, this angle also will be theta. This is the basic idea. Okay, so here we will write, this is the third case. Okay, we'll say that third case, ray going to pole will get reflected such that the incident and reflected ray make the same angle with the principal axis. Okay, the key point to, if you want to just at the key point is the incident and reflected ray make the same angle with the principal axis. This is what you can write in your book. Okay, Theta is the angle. Theta is the angle between the, okay, so here, see, this is my principal axis, okay, this is the incident ray. Again, watch, the ray goes from here, goes like this, and then gets reflected like this, correct? So the theta is the angle between the incident ray and the normal. I'll use a different color to show you. Okay, let me use blue color. See, this is the normal. Can you see this? The principal axis is also the normal here. Okay, the theta is this angle between the incident ray and the normal, and this is the angle between the reflected ray and the normal. And I'm saying that both of them are going to be equal. Does that make sense? Okay, I'll give you 30 seconds more. Please write it down. If you have any questions, you can obviously ask me. The class is till, okay, one of you asked how much time is the class. The class is till 8 o'clock, but I'll try to finish a little bit early if you want, and we can maybe just have a chat for some time. We can just have some fun conversation, but class is till 8 o'clock. Okay, got it. So now this is the third ray, and fourth, which I started discussing, but I did not finish it fully, which was that now I'll take the fourth type of ray whose behavior we know. So this is my concave mirror, this is the principal axis, this is, let us say, the center of curvature, this is the focal length. Now let us say if I have an object here, okay, the question for you is, if a ray of light goes to center of curvature, what will happen? And the answer is that this. Remember, I gave this example here. If you remember, there was that here, right? See, this is the center, right? So a ray which goes from center is nothing but it is the radius, and radius makes an angle of 90 degree with the tangent. So which means this ray will reflect and come back. So by that logic, a ray which goes along the center of curvature is, just watch how I trace it. Okay, it'll go from here like this. It goes, and then it'll this makes an angle of 90 degree with a tangent. Okay, so what will happen? This will go like this, and it will reflect like this. So which means it will go and come back in the same direction. So it will retrace its path. Okay, so now we'll write this. The fourth behavior we know, which is that ray through center of curvature will retrace its path. Okay, fantastic, good. So this is what, so now let's go through each of the four examples. Okay, first one was a ray parallel to principal axis, parallel will go through focus. Again, once again, ray parallel will go through focus. Okay, second behavior, ray through focus will become parallel, opposite. Okay, ray which is parallel will go through focus, ray through focus will become parallel. Third was a ray which goes to pole will get reflected such that it makes the reflected ray and the incident ray, once again, the reflected ray and the incident ray will make the same angle with the principal axis. And fourth is a ray through the center of curvature will retrace its path. These are the four. And I can tell you, children, I want you to know one thing. This ray tracing looks very difficult to a lot of students. Okay, I can assure you it's a cakewalk. If you understand these four things, so I'll spend enough time on these four things. If you understand this, your chapter is over. I mean, yeah, there's a lot more to study, but with this, you will be able to fly through the whole thing. You'll have absolutely no problem. Okay. So if you have any doubts, you can ask me. I'll give you a few. By the way, make sure that you have written, all of you, please take notes. Always when taking notes, reminder, do not copy from the screen. Understand and write in your own words. Do not copy from the screen. Let me know if we can move forward. Okay, Sabu says, please tell once again case number 4. Okay, so let me explain this. All of you just pay attention. I'll just do a recap. Okay, if you do not understand, if you don't understand, then you will understand this time. Okay, I can guarantee you will understand this. Till now, I think hopefully this. Okay, this is good. Guys, children, pay attention now. Okay, this is what is this? This is a circle, right? This is a circle. Now I am just asking you a simple question. Let us say this is the center of the circle. You will have to understand a little bit of geometry for this, very little bit. Okay, so this is the center of the circle. From here I draw a line. What is this line? This line is the radius. Yeah, very simple. Okay, now I'm drawing the radius. Now the question is, if I draw a tangent here, okay, let me draw it again. If I draw a tangent here, what is the angle that the tangent will, what is the angle between the tangent and the radius? What is this angle? This is something you have to know. What is it? It is 90 degree. Okay, so this angle is 90 degree, which we normally show using a square like this. Okay, so which means that the angle between them is 90 degree. Okay, next question. So now what you can do is, don't think about, forget now this. Till now we're talking about circle, which actually this is a sphere. I should have called it a sphere, not a circle. Okay, this is a sphere. I'm just looking at one at the edge of this. Okay, now let us say I cut the sphere from here. Okay, I cut it like this. If I cut it like this, what did I get? I got my spherical mirror. The spherical mirror is nothing but part of the sphere, isn't it? Right? Okay, so now you are clear about that thing. So I can consider this portion to be nothing but my spherical mirror. Okay, I'll draw it again like this. Okay, now you tell me. Now you can use your. Now let's say if I send if a ray goes through, this is the center of curvature. Okay, this is the center of curvature. A ray which goes through the center of curvature like this, what will happen? It will get reflected. Sorry, it will retrace its path. It will get reflected along the same direction, same path. If I take a ray like this, what will happen? This also will get reflected. Why? Because this is the radius, isn't it? A line along radius will always make 90 degree with a tangent here. So this ray which goes like this, it will come back. This will come back. This will come back. Any ray that you send will come back. That is the point. If you understand that, then I think you have understood why we said that a ray through center of curvature will retrace its path. I hope this is clear now. If it's clear, please everyone confirm this. Good. So I'm glad now it's clear to, I think it's clear to all of you. Right? So we are now making very good progress. Now it's 7:27. So I am going to give you another 5 minutes break. Okay. So it's 7:27. Take a break, 5 minutes, go and jump and play or have some coffee or tea or glass of water or milkshake or whatever you want, right? Go and have your drink something, take a 5 minutes break. At 7:32 I will start and I will give you some interesting problems. Now, by the way, I know that this was a lot of new stuff. Now we will actually be applying these principles and it will become very, very interesting. Okay, so we'll meet in about 5 minutes. Break time. Enjoy. Okay, okay everyone, we are back. Everybody is back. Now let's get started. Okay, so now we'll have some fun. Now whatever we have learned, we can actually get to apply those principles. So I'm going to now I will just sit back and relax and ask you questions, and together we will work out the answers. So let's start. First question. Are you guys all ready? I hope you're ready. Okay, first question. Let's start. This is a concave mirror. Okay, this is a concave mirror. Okay, now let me draw the principal axis. Every time you draw these things, like label everything. So this is the pole, we'll call it P. Let's say this is the center of curvature, this is the focal length. First question, which is pretty straightforward, I will not even spend this one. I will not ask you because we already done this. Let's say there was an object. There was an object like this. Now this object, let us say we one second, let me see if I can 1 second. Okay, so this object, let me draw it separately. Oops. Okay, now this object, let us say, was somewhere here. Okay, now I am moving this object back. It keeps going. Now it goes to infinity. You can't see it, right? But even though it has gone to infinity, it can send rays from there. Or it's very far, but it's sending some rays. So it's sending one ray which comes like this, parallel to the principal axis. What will happen? It will go through the focus. It sends another ray like this. What happens to that one? That also will go through the focus. Okay? So which means all the rays that are coming in, they are going to meet at focus. So the object will form what image will it form? It will form a point image at focus. It will form a point image at focus. This one I did not ask you because that's pretty obvious, so I'm going to just tell you this one. Then the more difficult ones I'm going to ask. Is this clear to everyone? No doubt, right? Now, one thing. Have you seen the proof of this? Right? I will actually switch on the camera because I want to talk to you now. Okay. So give me just 1 minute. Okay. I want to switch on the camera. Okay. So I just told you that that when the rays of light are coming from infinity, they are meeting at the focal point. What is the proof of that? So I have done an experiment. I will right now we are in lockdown, so those videos are actually in the office. So as soon as the lockdown is over, I'll share some very interesting experiment videos with us where we look at. So think about the rays of light coming from sun. Okay, so the rays of light of sun, they are coming almost parallel. Why? Because sun is very far away from there. So if you put a mirror here like this, right? So rays are coming. Put a mirror. What will happen after reflection? The rays will go and meet at a point. So it's like, when you use a lens, magnifying lens, you must have done that, right? You use a magnifying lens and we can see that the rays of sun can be focused at a point. Similarly, with a concave mirror also, all the rays that are coming, you can actually put a paper here and you'll see a very small bright spot. Okay, that is the proof, that is the actual demonstration of this. I promise you I'll send you a video on this as soon as the lockdown gets over. Okay, we have done a lot of experiments to demonstrate all these concepts. Okay, so let's now get back to our class. So this was the easy one. Now the hard one. The easy one I did for you, right? Hard one I will not do. By the way, here you can please write it down also in your notes. Okay, so first scenario is object at infinity. So point sized image, points as image formed at focus. This just take 30 seconds, write this down, do this diagram, right, draw this, and we are done with the first case. Second will be more interesting. Okay. "30 seconds. All of you have noted it down, I assume. Okay, so now we go to the next case, and this will be more interesting. I'll draw this. All of you just pay attention. Don't have to write or do anything. Just enjoy the class. Okay. Now this is the concave mirror. I will take, this is the principal axis. This is the pole. This is the center of curvature. Let me write in red color the center. This is the center of curvature, and half of the middle is going to be the focus. Now next is the object. Okay, an object for the first scenario was object at infinity. Okay, first scenario was object at infinity. Now second scenario we'll now bring the object closer. Okay, so object was at infinity. Now from here we bring. Now we bring here, and we say that okay, object is now going to be between, say, infinity, and so infinity is very far off here. So it's between infinity and center of curvature. Object between infinity and C. So let's say the object is, say, here. Now one thing which I want to tell you is the way we do the tracing is, remember all of you, we will take the top point. Okay, from here we will draw the two arrows whose behavior we know, and find where they meet, and then all the other points, okay, it will be on this at the same distance. I'll show it to you. First let's let's look at this particular point. Okay, this red point. Tell me, how will you find the image of this red point? Think and tell me. We can take two rays. Which rays do you want to take? There are many options. I have given you 4 options. Here you can follow all 4 options, but any 2 rays you can take. Which rays do you want to take? So I'll do the simple one, right? First I'll take a ray which is parallel to the principal axis. So first ray which goes parallel to the principal axis like this. After reflection, okay, it didn't go very parallel, so I'll draw it again nicely. A little better. Okay, so this is the incoming ray, and after reflection it will go through the focus. So once again, let me draw this a little nicely. Okay, so I still don't like it. One more time. This is better. Okay, so this is my first ray. One ray goes. Which other ray do you want to draw? So there are 2 options. What are the options? Actually, there are 3 options. Let's go through all the options. What are the options? First option is I can take a ray through the focus, and it will go parallel like this, or I can do a ray through the center of curvature, or I can do a ray which goes through the pole and get reflects and comes like this. So let's try one through the focus. Okay, let's do that. All of you do it. Okay, now you can do it along with me. You don't have to. Now we can start drawing. Okay, and you can do multiple drawings. You can try what I'm doing. You can draw some other ray. You'll get all of you will come to the same conclusion. Okay, second ray I will draw, let's say through the focus. Didn't come out well. Once again. Okay, this to the focus, and after reflection it will become parallel, so it will go and meet somewhere here. So now remember, one ray was this, second ray was this. I repeat, watch. Ray number 1 like this, and it came here, and ray number 2 goes like this, and it came like this. In fact, I'll extend this. It will not stop here, it will keep going, right? Which means this is the point, right? I'll use blue color. This is the point where the image is formed. Okay. Now, just to convince you that this is the case, if we were to draw through a line through center of curvature, let's draw and see. Okay. I draw a line through the center of curvature. Actually, let me draw it again. As you can see, the line through center of curvature also will, okay, this is freehand drawing, so it's not coming out that well, right? But if you draw it carefully, and if the distances, if this distance and this distance you measure, I have not drawn the distances properly, okay? But if you draw the distances properly, you will come to the conclusion that, actually, you know what, I'll move this, the center should not be here, the center of curvature should be more like here. Okay? That is what it should be. Yeah. Now we can see that, okay, with that drawing, this distance is equal to this distance. Okay. So now we can say that the line through the center of curvature will go like this, and this will come back. So all three of them, this one, and this one, all three of them, they meet at the same point. But like you said, we will not do 3 rays, we will do only 2, just for convenience. So this is going to be the image. So which means this point, its image is this point, and then rest I'll have to just tell you what you should do is, so this arrow is here. Now each of these points here, right, each point image will be formed, and the image and the distance will be the same. So which means the top is here, the bottom is going to be always along the principal axis. So this point, its image is going to be here. Okay. The bottom of the arrow, its image is going to be here, and rest of the arrow will just fill it up like this. Will not draw for every point. Okay. So now if I clean this up a little bit, now this become a little bit messy. If I clean this up, okay, now I like it a little better. Okay. Now if this was my object, this is going to be the image. Any doubts, you can ask me. Any doubts? I want to make this clean and everything. Okay. Any doubts, you can ask me, and you can now this image, what is it? First question, is it a real image? Yeah, it's a real image, right? Where is it formed? So observation 1, it's a real image. Real image. Why is it a real image? Because the rays are actually meeting, and if I had put a screen here, right, if I put a white cloth or something here, if these rays are, and let's say I put a cloth like, or paper like this, which is not blocking these rays, so all these rays will go and come here like this, so I will see an image here on the screen. I have done experiments where in those, I will show you those videos where you can actually see the image, literally, okay, you can see the image on a screen, but for now just take it from me. So it's a real image. Second question, is it inverted or is it erect? Very clearly it's inverted, right? This arrow is upward, this arrow is downward. Okay. So we see that the image is inverted. Third question, what is the position of image? Tell me, what is the position of image? What is the position, guys? Tell me. The position is between center of curvature and focal length, correct? Good. So position, this is going to be, position is going to be between center, C is center of curvature, and F, which is focus. And one final thing. Can you just look at it and tell me if the image is enlarged or is it diminished? See, this is the object and this is the image. Look at the size. Which arrow is bigger? Which one is bigger? This is bigger, right? Image is smaller, right? Object is bigger, image is smaller, which means image is diminished. So that is the observation number 4. Image is diminished. Okay, this is the first ray diagram we have done, and I am I want to make sure every one of you has understood this very, very clearly. Any doubts you can ask me, because this is, rest of it is just the same principle. Okay, it just looks hard, it is not hard at all. Okay, somebody is asking when the class will finish. The class will finish at 8 o'clock. But if you want, if you guys are tired, I can end the class right now and we can just talk for a few minutes. Let me know if you want to end the class now. I'll give you 30 seconds or 45 seconds. Just please take notes. Write it down now. Please don't copy from the screen. Look, understand, and write. Always write from your memory. Okay, now what I'll do is I will take only 5 minutes, and we will now do one more concept, one more question. Okay, very simple. You will do it yourself. In fact, I will not do. You do it. Okay, I will just help you do it. Next one is object is at C. Okay, now object is at center of curvature. Let me draw. This is the mirror. This is the principal axis. Let me draw again nicely. Okay, this I like. This is pole. Now let's say this is your center of curvature and this point is the focus. Children, now it's time for you to help me. I don't know how to do this. Okay, I don't know what to do. Now you have to tell me, this is the object. How will I find its image? Hint, what do you have to do? Take the top. Okay, take the tip of the arrow, take the stop point and find its image, and then rest of it, the rest of the arrow will be just, you finish, you connect it with the principal axis. That will be the image. Now how will you find the image? All of you do it. Which two arrows, which two rays can you take? Think and tell me. So we can always take one which is parallel to principal axis, correct? Let's do that. Very, very simple. So we'll take one which is parallel to principal axis. Let me use the red color itself. Okay. So one which goes like this. Do your own drawing, okay? Don't just look at now. This one I want you to do on your own notebook and do it and figure it out yourself. Okay. No rush. We'll not do any more cases. This is the last we are doing. So this ray goes like this. After reflection, we know that it will pass through the focus. Okay. Another one we can draw. Now there are two options. One is we can draw through focus, or we can do one through the pole. So one through focus is going to be a little easier to draw. So we'll draw one through focus. One through pole also will be correct. Nothing wrong with it. Okay. Let me just draw again. Yeah, and this will get reflected. It will go parallel to the principal axis. And 1 second. And it will meet here. Okay. So this is going to be the image, and this was the object. Actually, what I'll do is I'll draw the image in a different color so you can see it a little nicely. Okay, I'll draw the image in blue color. Okay, so this is the tip. So your image is going to be This is going to be like this. Okay, so this is your object and this is your image. So we see that the object and the image distance is the same. So now let's, like here, remember we first we looked at whether it is real or virtual, inverted or erect, and its position, and whether it is big or small, right? Let us answer all those questions one by one. First, real or virtual? Tell me, real or virtual? It's real, right? Because the rays of, remember these rays, this is ray number 1 and this is ray number 2. These two rays, they are actually meeting here. They are coming from here and they are meeting at this point, right? So this is, we'll say that this is a real image. Second, is it erect or inverted? Very simple. The object is upward. This arrow is upward. This is a downward arrow, right? So now we can say that it is inverted. Okay. Third, what is the position? Where is the image formed? So image and object both are formed at center of curvature, right? So image at C. And fourth, I have not proven it to you, but visually, just if you look at it, what does the size look like? Both of them, they look like they have the same size. In fact, later on we will show you, when I give you the formulas, I'll show you that they are mathematically they're going to be equal. So the image is neither enlarged nor is it diminished. Okay, so we'll write image same size as object. Okay, these are the 4 things. That's it. No more teaching today. Now we can stop here a few minutes. We can ask questions. We can talk about anything you want. Any doubts you have, you can ask about class 10th. You can ask about anything in the world, right? So you can ask about this particular thing. Please note it down, not by copying from the screen. Think and write it in your own words. Do your own drawing. That's it for today. Yes, Adityan has given the right answer. So real, inverted, and at center of curvature. Very good. See, now once you understand these things, rest of ray diagram will be very, very easy. And I can assure you, if we had not understood this, it will always be, oh my God, very difficult. What is happening? What is this ray? Why is it going? Why are we doing only 2 rays? Nothing of that sort. Now we know how to do this. Yes, so we can do some fun chat. Tell me. Okay, bye Joseph. Enjoy your evening. Bye everyone. Okay, children. What else? Are you going to have dinner now? What is the plan? What are you having for dinner? All are bored? Okay. Too much studies, is it? Why are you bored? Okay, and why did I quit my job as an IPS officer? Well, I worked for 8 years and it was, I think it was a long time. I wanted to do something different. So yeah, so that's why I like teaching. Which is my favorite dish. I like mutton curry. I also like tandoori chicken, but I like mutton curry a lot. Yes, I am very fond of dosa also. Dosa, idli, sambar. So I live in Trivandrum. So there is a restaurant called Arya Nivas here. I like going to Arya Nivas. Now of course everything is shut down, so we just make it home. So yeah. Okay, children. So now it's 8 o'clock. So now chill, relax. Don't have to study now. Go and have a nice dinner and play with your friend. Well, friends are not going to be available, so do some fun stuff and then sleep early, and I'll see you again. Thank you for joining. I hope you enjoyed. If you have any questions, you can always ask me. Okay? Enjoy. Bye. Take care. And as a question, are you Malayali or a Punjabi? I'm not a Malayali. I'm also not a Punjabi. I'm from UP. My favorite movie is I like this movie called Saving Private Ryan. It's a war movie. I like. Okay, tell something about coronavirus. Mm, well, you know everything about corona. There's nothing new to say. Just be very careful. And yeah, if you want, I can share a video I'm going to make on that. But very, be very careful. Okay, bye. Good night, everyone. It's 8 o'clock. So we will end.